Modes of propagation of electromagnetic waves. Hello friends, in this video I will discuss the different modes of electromagnetic wave propagation. Depending on the frequency range, there are 5 different modes of electromagnetic wave propagation. These are ground wave propagation, sky wave propagation, space wave propagation, duct wave propagation and troposcatter wave propagation. Ground wave propagation. This mode of propagation exists when the transmitting and receiving antennas are close to the surface of Earth. Ground wave is a wave that is guided along the surface of Earth as an electromagnetic wave and is guided by a waveguide or a transmission line. It is produced by vertically polarized antennas. Any horizontal component of the electric field with Earth is short-circuited by the Earth. When these waves move over the Earth, the energy of surface wave decreases due to the absorption and the Earth attenuation. This attenuation of Earth increases as the frequency increases. Hence, this mode of propagation is suitable for low and medium frequency, that is up to 2 MHz only. Ground wave will travel long distance on sea surface due to high conductivity of sea water. Hence, it is mainly used for ship-to-ship communication and AM broadcasting. In sky wave propagation, electromagnetic waves reach the receiving point after reflection from ionized region in the upper atmosphere called ionosphere, which lies between 50 km to 400 km above the Earth's surface. Frequency range in this mode of propagation is 2 MHz to 30 MHz. Sky wave propagation are used for long distance radio communications. In case of a space wave propagation, electromagnetic waves from the transmitting antenna reach the receiving antenna either directly or after reflections from the ground in Earth's tropospheric region. Space wave is mainly used for frequencies above 30 MHz, that is very high frequency. At such frequencies, sky wave and ground wave fails. In this mode of propagation, although the wave leaves the transmitting antenna at the same time, but they may reach the receiving antenna either in phase or out of phase because of the two waves travel different path length. Space wave are also known as line of sight propagation, and it is limited by the curvature of Earth. TV signals of the frequency range 80 MHz to 200 MHz uses LOS propagation or a space wave propagation, as the signals are not reflected by the Earth's ionosphere. It suffers multipath fading because of the reception of multiple waves. Duct wave propagation is based on the principle of super refraction, which is caused by temperature inversion. At very high frequency and ultra high frequency, the waves are neither reflected by ionosphere nor propagated along the Earth's surface, but the transmission occur beyond the line of sight distance due to the refraction of such high frequency waves in the ionosphere. Due to turbulence in air, different layers of air have different temperatures and vapor contents, which leads to the formation of air forming a duct or a sort of leaky waveguides, which guides the electromagnetic waves between the walls. The main requirement of duct formation is temperature inversion layer. In the inversion layer, the temperature increases with height rather than decrease of temperature. In this temperature inversion layer, the wave travels along the surface of Earth. Tropospheric scatter propagation is used for the frequency above 300 MHz. Scattering of EM waves in troposphere occurs due to the presence of common volume, where common volume is due to the presence of water vapors in free space, which makes it a scattering center. The molecules having different atmospheric turbulence will form a common volume in troposphere. When the EM wave is transmitted towards the common volume, then it will be forward scattered if the signal frequency is greater than the common volume frequency. There are various types of scattering present in this system, like backward scattering, lost scattering, and forward scattering. Forward scattering is mainly used for point-to-point communication, radio, or television relay links. The tropospheric scatter propagation is used to provide the long-distance telephone and other communication links in inaccessible area. Troposcatter links are useful in multi-channel and television application. The cost of installation of this mode of propagation is very high, and this propagation is suffered by both type of fading, fast fading and slow fading. For more detail, visit our website easyelectronics.co.in.